Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with 12th Standard Mathematics Paper 1, First Chapter, Mathematical Logic, Part 8. We already studied algebra of statements, find the negation of using rules of negation, etc. in the previous video. So today we are starting with the topics application of logic to switching circuits. In that, types of switches, circuit, input output table or switching table, etc. So, application of logic to switching circuits. So, first we will define switch. A switch is a two-state device used to control the flow of current in a circuit. You are all studied circuit and switches in physics. So, it is similar to that only. We are just using notations, etc. That's it. So we shall denote the switches by letters S, S1, S2, S3, S4, etc. for switches. Switch S is marked in figure. There are figure 1.1 and 1.2 is given. In figure 1.1, only one switch is marked. And figure 1.2 is a circuit which containing an electric lamp L, battery and switch. Circuit. When the switch S is closed, that is on, then current flows in the circuit and hence the lamp glows. Here you can see one red marking, that is the switch closed symbol. When the switch is closed or on, the current flows through the circuit. When the switch S is open, that is off, the switch will be like this. Then the current does not flow in the circuit and subsequently the lamp does not glow. For a given statement pattern, a circuit can be constructed. So we already studied statement pattern and all and truth table, etc. So through circuit also you can do the table, but here the table is called switching table. So this is one example given here for statement pattern. So here P, Q, negation are three switches are given, but Q is repeating twice. So corresponding to each switch in the circuit, we take a statement letter P, Q, etc. So here three switches are given. Switches having the same state will be denoted by the same letter. So here Q is repeating twice. That means in the circuit, the switch Q or S2 is repeating two times. So that kind of switches are called equivalent switches. Switches having opposite states are denoted by S and S dash. So one example is given here. P and Q implies negation P or R. Here again P, Q and negation P, R. So four switches are given, but P and negation P are opposite states. So they are called complementary switches. For the given statement pattern, P and Q implies negation P or R. So we have to describe this P, Q, R, etc. Like this. So P, let P, the switch S1 is closed. Q, the switch S2 is closed. R, the switch S3 is closed. And here negation P is also given. So negation P, the switch S1 dash, that is the difference in between P and negation P. The same notation we are applying, but the switch S1 dash is given, that is closed. L, the lamp L glows. This way you have to explain. If there are two switches S1 and S2, they can be connected in two ways. One is in series, another one is in parallel. So the two way you can arrange the switches. So types of switches arrangement is in series also, in parallel also. So two way you can arrange. First one, switches in series. In this figure, you can see switches S1, S2 are arranged in a single line. So it is called in series way. Okay, and the lamp L is connected here, battery is also there. So symbolically, if switches are arranged like this, you can denote P, Q, etc. You have to arrange, and then you can write symbolic form as P and Q. So here switches S1 and S2 are in series. And this way you will denote P, the switch S1 is closed, Q, the switch S2 is closed, L, the lamp L closed. Now switches in parallel. Here you can see in figure 1.4 there are two switches again, but the switches are arranged in parallel way. Here again you have to apply P, the switch S1 is closed, Q, the switch S2 is closed, small letter L, the lamp L closed like that. So here the symbolic form of this is P or Q. So if it is parallel, then or symbol is the denotation, and switches S1 and S2 are in parallel. Next is input output table or switching table. This is similar to our truth table, but the difference is instead of writing true, we will write 1. Instead of writing false, we will write 0 in this one. So we consider all possible combinations of states of all switches in the circuit and prepare a table. That is called input output table, or it is also called switching table, which is similar to our truth table. In an input output table, we represent 1 when the state of the switch is on. Switch is on means this current passing through the circuit, okay, and 0 when the state of the switch is off. So instead of writing true, we are writing 1 here, and instead of writing false in the table, we will write 0. If two switches are in series, say S1 and S2, then the circuit will look like this, and you have to write this way. Let P, the switch S1 is closed, Q, the switch S2 is closed, L, the lamp L glows. Now the symbolic form of this is P and Q. Now we can write the table as like this. P, Q, P and Q as it is as truth table. Only difference is that instead of writing true, here we are applying 1, and instead of false, we are using 0. So 1, 1, 0, 0, Q value 1, 0, 1, 0. So P and Q, 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. If two switches are in parallel, say S1 and S2, then the circuit figure 1.4 you can see here. So this way switches will arrange. Again you have to let P, the switch S1 is closed, Q, the switch S2 is closed, L, the lamp L closed. Now the symbolic form of this is P or Q. Now we can represent this in switching table as like this. P, Q, P or Q. Here again these two tables you can write columns as like this. Now P or Q value is 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, 0 or 0 is 0. Express the following circuits in symbolic form of logic and write the input output table. So we'll discuss with one example. This is the circuit given here. Here S1, S2, S1 dash, S2 dash. Actually, 4 switches are given. S1, S1 dash are complementary switches. S2, S2 dash are complementary switches. So you have to assume let P, the switch S1 is closed. Q, the switch S2 is closed. Negation P, the switch S1 dash is closed. Negation Q, the switch S2 dash is closed. L, the lamp L closed. Now we have to write the symbolic form of this one. All this one S1, S2, S1 dash, S2 dash. All these are parallelly connected actually. So first you will write S1 as the symbol P and S2 Q. So P or Q or next switches are in series arrangement. So negation P and negation Q, that you have to put inside one bracket. And here we can put it in also in bracket. Now we have to write in tabular form. Switching table is like this: P, Q, negation P, negation Q, then we will write P or Q, then negation P and negation Q, then the full statement you can write in the seventh column. Now the values as it is, this you know all this. Only difference, instead of writing true, we are writing here as 1, and instead of false it is 0. Sorry, yeah, instead of false it is 0. Now all these values you can find it as it is, like truth table. Next example is express the following circuits in symbolic form of logic and write the input output table of this. This is 1.6, figure 1.6, and here it is S1, S2, S1 dash, S2 dash, and S3. So S1, S2, S3 are present means PQR you have to write. Then S1, S1 dash are complementary switches, S2, S2 dash are complementary switches. So negation P, negation Q you have to write, and L. Now the symbolic form of this is, here S1, S2 are arranged in series, S1 dash, S2 dash arranged in series, but these two sets are arranged in parallel. So first this is P and Q, that you will put inside one bracket, or negation P and negation Q, again you will put inside one bracket, and these are all four switches are connected in series with this one. So and you have to write, and R you have to write here. So this one you can put inside the closed bracket. Now the symbolic form you written over here. Now you have to do with a table. Switching table PQR, three statement letters are here. So 2 raised to 3, 8 rows will be there. So instead of writing true, you are writing false ones, and instead of writing false, you are writing zeros. Remaining are same as the truth table. So procedure is same. So you can complete this one. You'll get the answer. Here, instead of writing the full statement pattern, I have given value A here. So in ninth column, A or R is used. Next is this one, S1, S2, S2, S3, S1 dash. Here, S1, S2, 2, 3, 4, 5 switches. So you have to write S, P, Q, R, negation P, and L. This way you will write all these values. Symbolic form is, here two switches are arranged in parallel, then it is that set is arranged in series, again one more set is given. So first set is P or Q, inside the bracket you can write that, and this is Q, and next inside the bracket R or negation P. The table you can write like this. So PQR, so 8 rows, negation P, then P or Q, then P or Q and Q, then R or negation P you have to find out, then you have to complete like this. So here again I have given A for this statement pattern. Now in ninth column I have just applied that. Now some exercise questions. Express the following circuits in this symbolic form. Prepare the switching table for these two questions. Thank you.